Yeah, we'll start. So let me know whenever we have gone live so I can start. Okay, thank you. Thanks, Balaji. Okay, good afternoon, everyone, and welcome to this second live session on the Matlab course. Okay, and I have a few questions with me, and I'll answer them. Okay, I think there are a few students who have asked how exams will be conducted. So I think I had gone over that once, but let me go over it once again. Okay, so the exams will be pen and paper based exams. Will be basically it's an online exam, which means you will be in front of the computer, but you will not have access to Matlab. So you'll be solving problems using calculator and not using Matlab. So the type of questions that an exam pattern, I will come to that at an appropriate time. But there would be, some questions like this. So one question could be, let's say, if a equal to 0.25, what is log a? Okay, so this answer you will have to give. Now, log a, this becomes kind of an interesting question from MATLAB viewpoint, because the command log in MATLAB is a natural logarithm. It computes ln, right? So you should know that MATLAB basically it computes ln when you give the command log. The other type of question would be, what is the command to compute tan inverse of x? Okay, and the answer to that would be, let's say, a tan. Okay, the example from the current week's material, what's the MATLAB command for solving a set of nonlinear equations? So the MATLAB commands for nonlinear equations are f0 and fsolve. Okay, so this would be one type of question. So the first one that I gave was a numerical question. The next three that I've given was alphanumeric type of question. Other type of question would be, let's say, MCQ. Okay, MCQ would be for example, which method is used for solving a set of linear equations. Okay, so one of the answers I might have given is Gauss elimination. Remaining three answers would be, or remaining 3 or 4 or 5 answers would be different. So that would be MCQ, or it could be MSQ. So again, same question, which of the following methods can be used to solve a set of linear equations? And I might have given Gauss elimination and Jacobi iterations as two options, and both of them have to be marked correct. If you mark any of the wrong answers, then you'll get 0 points. If you mark both the correct answers and none of the wrong answers, you will get full marks. If you mark only one of the correct answers, but not the other, and you don't mark any of the wrong answers, then you will get half the number of points. Okay, so that would be examples of MCQ, MSQ. The third one is going to be match the following. Okay, so the left hand side, I will give names of MATLAB commands, for example, f0, fsolve, trapz. What else have you seen so far? Let's say these are the three. And on the right hand side, I'll give you what they are used for. 1, 2, 3, 4, 5, 6, let's say. Okay, so you have to match them. So f0 can be used for this, fsolve can be used for this, trapz can be used for this, right? So this is the other type of question that I would have. The fourth type of question is a longer problem solving question. So where I will ask you a question that basically tests your funda about MATLAB, but a little bit about what MATLAB is doing, or how it is implementing. So, for example, I can give you a vector and ask you, what does trapz of that vector do, and I will ask you to give the value. or I can give you a vector and I can say, comprod. What's the size of the vector that results out of comprod? So those are the type of questions. So they will involve two things. One is they will involve the concepts of MATLAB, and second is they would involve solving a fairly small problem where you will require calculator. Again, you're not allowed in the exam, you're not allowed your own calculator. There will be an online calculator that you will have access to, and we will provide a link to the online calculator probably in the 7th week of this course, so that you can test it out and you can try it out. I don't know exactly when the team would provide that. Maybe they have already provided, I don't know. But definitely a week or two before the exam, at least, we will provide a link to that. And another type of question will be spot and error. Okay, an example for that would be, say, x equal to 5, y equal to capital X squared. Okay, so I'll ask you which line the error is. The error, of course, is in this line. I can ask you, why do you think that error is obtained? And that is because variables are case sensitive. So I might ask you, what is the error that MATLAB is most likely to spit out? So in this case, it will spit out an error, although it is because of variables being case sensitive. MATLAB doesn't know that you meant small x and capital X to be the same. So MATLAB will give an error which says that x is not defined. Okay, something like this. Again, try this out to know what exactly the error, what exact error MATLAB gives, and you'll be able to figure those things out. Okay, so these are the type of questions. Probably early next week, along with week 6 material, I will also release a PDF file which contains the list of all types of questions that would be asked in the exam. The other question was, how is the split up marks split for the exam? I'm not sure how the mark split exactly would be, but I would say each week would count for anywhere between, say, 8 to 20% of the total marks. Uh, Again, I'm giving you a broad range. It's I can't guarantee you exactly 1/8. I don't do that. But there will be questions that will come from each of the 8 weeks. Okay, and if you'll see, I've taken a very, very practical approach to the entire 8-week course. So I'm directly solving things in front of the camera and in the videos. You can actually see the entire code in front of you as I'm typing. I'm making errors right in those videos and I'm debugging them. And exact same process you will also have gone through when you try to do your assignments. So if you have done the assignments by yourself, the exam should not be terribly difficult. There would be a few things that might be confusing simply because it spans the entire 8 weeks worth of material. But as such, there are no intentional googlies or there are no intentional trick questions at all in the assignment. So assignment is supposed to be testing your expertise that you have gained in the 8 weeks, learning about MATLAB and about the numerical methods that are being solved in MATLAB in the relevant in the 8 weeks. Okay. Okay. Syntax of X versus C++. How do you compare the two? That was one more question. Okay. The first thing of comparison is variable declarations. are not required. Okay, so you don't need to say the int part. Sorry, yeah. Okay. The other thing is that the how what the function will output and how many outputs will a function have is determined by the function file. This will be the first line in a function file. Okay, and let's say this is the function file. Okay, so out1 is x to the power a, out2 is tan inverse of x. Okay, so these are the outputs. Okay, from the command line you can call, if you call the function as let's say 1 comma 5. Okay, this will just output the result as ans equal to 1. Why? It will calculate 1 to the power 5. The value 1 to the power 5 is returned in out 1. It will calculate tan inverse of 1. Pi by 4 will be returned in out 2. But you have nothing to capture the values that are returned. If there's nothing to capture values that are returned, it's captured in the variable ans. Okay, so only first value is going to be captured in the variable ans, and therefore ans will get the value of 1. If instead you all were to call this function as out2, okay, again you will get the result as out2 equal to 1. Why does that happen? That's, as I have said while defining the functions, that this variable name has absolutely no meaning when you are calling it from outside. When you're calling it from outside, all it knows is that I have to give you two values. First value is 1, second value is 5. Func name takes those two values and says, okay, first value is 1, which I will assign to x. Second value is 5, which I will assign to a. I will do the calculations. I will return two values. The first value that I return is going to be x to the power a, out 1. Okay, irrespective of how you call it in the command line, the first value returned will be the first output argument. Okay, and that's why irrespective of how you call it, this is how it will be returned. Of course, this is a contrived example. Most people won't put it like this, but very likely you would do something like res equal to, where res stands for result, and this is what you will get if you are calling this as res comma tan in val equal to func name 1 comma 5. Okay, then res will get the value of 1, tan in val will get the value of 5. Okay, this is how functions work. Now the other reason to use functions is to be able to really use them as f of x. And if you want to use them as f of x, you can call them as, let's say, at uh, let's say I will call this as z. Okay, what does this tell Matlab? What this tells Matlab is that this is a function f of z. Okay, what is f of z? F of z is func name called using the variable z as the first argument and called using the value 3 as the second argument. Okay, so this is how this particular thing works. Okay, so let us say you had a function in two variables. Okay, and you wanted it to be used for two different purposes. Say integral okay, you'll be able to use this for both these purposes, provided that f is the same. Okay, how to call this? You will call this as at x, because x is the variable of interest, func name x comma 5. How will you call this? We'll call this as at y, func name 0 comma y. Okay, note that x and y are dummy, which basically means you can very well replace y with anything else. Okay, I can call this as r. Okay, of course Matlab doesn't allow Hindi names, but if it was allowing Hindi names, you can call this as k and this also k, and it would still be okay. Okay, the concept is that this are dummy, and Matlab recognizes what variable it is when you use the same letters or the same set of characters to represent both the things as the variable as well as the location in the func name arguments. Okay, so again, to keep things simple and to keep things right, I will again call it as at y func name 0 comma y. Okay, this is how functions in Matlab work. So if you compare what it is in comparison with C++, you will notice that the C++ functions do not give you anywhere close to the flexibility that Matlab functions provide you. Okay, Matlab functions are a very flexible tool. Why? Because Matlab is a software for numerical computations and for various applications related to that, and that's why it has certain powerful features, and use of the functions in this particular way is a very nice feature that that Matlab has. It's not necessarily unique to Matlab, but it's very strongly implemented in Matlab. Hopefully that answers this question. Let me see if there are follow-up questions that have come. Generally in the books, Niranjan, generally in the books, course starts with linear equations or nonlinear equations. Is there any reason why this course starts with numerical differentiation and integration? No real reason. The only reason is that linear equations and nonlinear equations, in my mind, they should follow each other. Differentiation and integration, it's a good idea for them to follow each other. Interpolation and regression, it's a good idea for them to at least follow the linear equations and nonlinear equations part, although linear and nonlinear equations are not explicitly used in them. And that can be followed by, if, for example, if this was a 12-week course, I would have had optimization that would have followed linear and nonlinear equation. But only there's no real reason why linear and nonlinear equation comes after numerical differentiation and integration. They could have very well been switched also, and it would not have mattered. The only thing that kind of I did it this way is because in the error analysis, I was taking the example of numerical differentiation. So it was kind of, when I was recording the videos, it was just natural for me to do it that way. So that's probably the only thing that I can think of. So no, there isn't a specific pedagogical reason for numerical differentiation integration coming before linear nonlinear equations. Okay. Yeah, exam demo done. Elaboration on the syntax of functions is done. Uh, I'm finding it difficult to understand the concepts of linear equations like LU, Gauss-Seidel. Uh, okay. Okay. So I'll take this as a two-part question. One is I'm finding it difficult to understand LU decomposition, Gauss-Seidel, and all that. If that is the case, please brush up on your concepts of numerical methods. So any standard numerical methods textbook is going to work. I also have a numerical methods course. So if you go to nptel.ac.in, okay, there in courses search box, search for my name. I think just first name is going to be okay. Search for that name, and there will be one of the courses that will be there would be numerical methods. Just go to this course and you will find the theory behind all the numerical techniques that we are covering in MATLAB. In the MATLAB course, I'm really giving a practical feel for how to use MATLAB. In the numerical methods course, I go over how to do this, how to solve, how to understand numerical methods. That numerical methods course was done the previous semester on NPTEL. So you'll be able to get your concepts cleared out from that course. Okay. The other question, other follow-up part was that I literally copy your code without understanding much. The reason why I have not shared the MATLAB M files with all of you is because I think there is a value in even just literally copying the code from screens onto your your own MATLAB screen. There is a little bit of a value in that. Why? Is because you are beginning to use some brain muscles. Okay, lot of times all of us we have what in chemical engineering we call, or chemistry we will call as activation barrier. Right. So if you look at how reaction takes place, there's an activation energy. Okay, all of us, myself included, have that activation energy. The whole idea behind you looking at the screen and even copying down the code that I have written blindly, the whole idea about that is to help you get over that activation barrier. So even if you are blindly copying it down, if you spend a few minutes to pause and think about what is happening, uh, and why are particular statements written in a particular way, hopefully that will clear things out. And in fact, that is, in my opinion, a good way of learning. You may or may not reach your learning goals. Yes, that is possible. However, this I think is still, you would still end up learning a lot more than if, for example, you're only looking at the videos and not typing out the codes. So I would in fact encourage you to continue typing out the code. Hopefully in by now or in a week or so, you will get more comfortable with the syntax of MATLAB, so that then you can focus on the concepts. Go back to week number 1 and 2, restart from there. If you do have time, restart from there and see whether or not you have actually understood a little bit more now than when you first watched the videos. I can guarantee you that you would have understood you a little bit more now than when you first started watching the video. So what you have suggested is, except if I take out the word blindly, what you have suggested is essentially what I wanted you to do, to take a look at the video, to see the me doing the codes and then repeat the codes. make mistakes, correct those mistakes by pausing my video and looking at my code. Try to think about what those mistakes are. Try to think about when MATLAB throws an error in a red color font, what that error means, why that error came. When you edit that particular line of code, try to think about why editing that line of code got rid of that error. And that's essentially what is needed for you to do well in this course and understand MATLAB well. Can you please provide solutions to assignments? Yes, I think in between one assignment we have failed to provide the solution. I don't remember why. Probably because the teaching assistant had exam or project review or something like that. I will check. In fact, NPTEL office reminded me this morning itself that one of the assignment solutions is not uploaded. And I think that is probably assignment 4 or assignment 3 solution. So I will take a look and I will upload that by the weekend, before the weekend I'll try, or during the weekend I will try to upload it. Yes. Is it possible that in exam we might be asked to no, you Shah Puja, we will not ask you to write very long pieces of code. Maximum, I'll ask you to write 2, 3 lines, 4 lines of code. Definitely not more than that. If I remember correctly, the maximum number of lines of code in any question that I ask is literally 1 line of code, and sometimes not even an entire line of code. So yeah, you don't have to worry about writing 10 lines of code and so on. One. Second is, even if I'm asking you to write 10 lines of code, which I'm not, but if I were to ask you to write 10 lines of code, I'm basically looking for two things. One is whether your logic is correct and whether you are used the correct MATLAB functions. I'm not verifying whether or not the MATLAB syntax is pakka spot on. What I mean by that is, let's say you are doing tan in your code, you require tan inverse. Okay, I will verify whether you are using atan as the command for tan inverse. If you are using ln, the natural logarithm, I will verify whether or not you are using log. If it's a log to the base 10, I will verify whether or not you are using log 10. Okay, but I will not be nitpicky about the syntax for a 10-line code. But again, there's no 10-line code. I used to ask 10-line codes 6 years back. I have stopped asking them because I have now realized that there is a more fun and more informative way of asking the question. For example, by giving a 5-line, 6-line code to you and asking you to identify what if there is an error in any of the lines. Or I will give, let's say it's an 8-line code, I will write 7 lines, 8th line will be blank, and you will have to fill that blank. Those are the types of questions with respect to coding questions that will come. Okay, but I cannot, if you don't have access to MATLAB, I cannot, of course, ask you a 10-line MATLAB code and then expect you to have the syntax exactly right. Okay, but for example, I will test you on the fact that fsolve solves a multivariate nonlinear equation, whereas f0 solves a single variable nonlinear equation. If you use f0 to, let's say, for a regression problem, sorry, you're not going to get marks, because that's not about syntax, but that's about concepts of MATLAB. For example, if you use TrapZ, which is a trapezoidal method solver, in order to for example, solve an interpolation problem, yes, you're going to lose marks, because that goes into the background information about what particular code of MATLAB is going to be used for. Okay, so hopefully that is clear. Okay, we'll continue with. There is one more question, that Abhishek's question, which I will not yet take it up, as I have not understood linear equations, LU decomposition, Gauss-Seidel, tridiagonal. So what can you explain? I'll take that up. Ayush has asked a question. Can you please explain the working of show matrix.m? Sorry, Ayush, the answer to that is no. No, it's not like I don't want to show. My past experience is that when I have shown in the first year that I taught this course, when I showed show matrix.m, it was total confusion among students. So that's why I'm not showing. But what does show matrix do? Let's say I have L D U. Okay, and let's say L is 1 2 3 4, D is 10 20. Okay, what does show matrix do? Show matrix just converts it into a 5 by 5 matrix such that D is 10 20 30 40 50. L is the lower triangular, so it's 1 2 3 4. U is upper triangular, so it's -1 -2 -3 -4. Others are 0. Okay, show matrix just converts this into this matrix. It was just meant to show you that, you know what, the values of L, D, and U that you have put in are exactly what one would expect. That was all the intention of that code. I have in the past, on students' request, shown that code, and trust me on this, is that it had actually led to more confusions than students understanding it. Okay, so that therefore let's not worry about that. Okay. Can you explain tridiagonal matrix? So Neha and Abhishek's question, I will take them together. Can you explain LU and Cholesky factorization? So any matrix A can be decomposed in multiple different ways into two matrices, let's say L and U, where L is a lower triangular matrix and U is an upper triangular matrix. And the same similar concepts work for Cholesky factorization also. Cholesky factorization, again, you look it up. You can literally do a Google search, and the first 5 links are going to be very, very useful links. You can pick up any numerical methods book and look at Cholesky factorization and the numerical technique that can be used to do Cholesky factorization in an efficient way. And you can just expand the concepts that you have learned in this course or to do Cholesky factorization. Probably you may want to wait until the 8 weeks are over so that you're a lot more comfortable with MATLAB. But yes, you can look that up. There's a Cholesky factorization code that is available in MATLAB, and you might check it out to see how MATLAB does. But one of the challenges with looking at MATLAB code is the main code might be 5 lines, but there would be about 50 lines of code for error checking and spitting out the diagnostic information if there is an error, if there are warnings and all that. So the code is usually at least 3-4 times up to 10 times larger than what a code you yourself would write, and that's because of all this error checking and so on. So yeah, I won't recommend looking into MATLAB's own Cholesky factorization code, but there are a lot of good books that are available. Coming to LU decomposition, is that the idea is that any matrix A can be decomposed in terms of a lower triangular matrix multiplied by the upper triangular matrix. And one of the ways to get, it's not the only way, one of the ways to get L and U matrices is by using Gauss elimination. Okay, U matrix is nothing but the matrix that is left after Gauss elimination. So let's say you had matrix 1 2 3 4 5 6. Maybe I won't do it like, yeah, 1 2 3 4 5 6 7 8 9. Okay, so in order to make 0 in the first pivot column, you're going to have 1 0 0 and 2. 5 minus 8 is -3. 8 minus 14 is minus 6. 3, you have 6 minus 12 is minus 6. And you have basically 9 minus 21 is minus 12. Okay, this is what you get over here. Okay, and minus 4 and minus 7 are the multiplying factors that you have used. Thereafter, you're going to get 1 0 0, get 2 minus 3 0, you'll get 3 minus 6. So yeah, so oh well, this one is not yeah, you won't be able to decompose this, I think. Maybe I should have used some other number. I should have used 10 minus 11, and then this is 1. Okay, so this is what you get after your Gauss elimination. The matrix that you get after the Gauss elimination is the U matrix, and the matrix that is composed of the multiplying factors. In this case, this is 2. So minus 4, minus 7, minus 2, and then 1 1 1. That becomes your L matrix. Okay, so it's the concept is as simple as that. And if you multiply the L matrix that you get and the U matrix that you have, you will actually find that you are able to recover the original A matrix that you originally started off with. Okay, that's the concept of LU decomposition, and that exactly that was what was done. Is because we have spent so much time doing Gauss elimination. I thought, okay, you have the U matrix that has already come out of Gauss elimination. You had your alpha values that you had already stored when you did Gauss elimination. You can just put them all together in order to get the L and the U matrix. That was the primary concept of LU decomposition. Okay, another question. Why have you used ABS? Oops. Why is max required? Okay, let's say X was 1, X new was 1.2. Okay, error is nothing but 0.2. No problem, you don't need a max, just ABS would be okay as well. Max was used in linear algebra part where our X was not this, but let's say X was 1 2 3. Okay, then is going to be 1 minus 1.2 is minus 0.2. 2 minus 1.4 is 0.6. 3 minus 3.1 is minus 0.1. Okay, ABS of this is going to be this. Max of ABS of this is going to be max of this, which is equal to 0.6. So this is the error when you have vectors. Okay, if it was scalar, it's just x minus x new, you take the absolute value, you're done. When it is a vector, you are looking at the worst or the largest error amongst all the variables that are present. It's also known as the infinity norm. Okay, so that is why we have used max ABS x minus x old or x minus x new, whatever the case might be. Okay, what type of problems can be implemented using MATLAB? In each week, probably the last two problems are examples of very simplified 1 or 2 or 3 variable examples of what can be done in MATLAB, except for week number 1 and 2, but weeks 3 onwards, that's what we are doing. So one of the examples that I would have given in differentiation is, so one of the examples I gave in numerical differentiation and integration is the heat transfer problem. Okay, it was very simple. There's a ball of fruit, the entire fruit is at one temperature. But in reality, that's not going to be the case. In reality, it need not be fruit, but it can be something else. It could be, how will you design, for example, let's say the air vents that are present inside a refrigerator so as to cool that particular apple in the fastest way. How will you cool the apple in the fastest way? By increasing the value of H to the highest possible value. How will you increase the value of H? By solving these type of numerical problems, and you figure out what airflow gives you the best cooling. That would be, for example, that would be one example. The other example would be in linear systems. The example that we took is that, I don't know if we took a reactive example or a heat conduction example, but this particular screen that I have, this is not a computer, this is a screen. It's connected to a computer. The computer has this computer chip, and if you have seen the chip, there is a, aluminum spreader, what it is called, for cooling the chip. Okay, that spreader has a finned structure. If you look at one particular fin of that aluminum structure, one end would be hot. It would be the temperature that the computer chip is at, probably 120 degrees, 80 degrees, 70 degrees Celsius. The other end and the sides are exposed to the atmosphere. Because of their exposure to the atmosphere and because of the fan rotating, you will have cooling that is going to take place. So the temperature is going to vary from 100 degrees Celsius to, for example, 25 degrees Celsius along the length of that fin. And that's the problem that we have taken, is how does the temperature vary along the length of that fin? I will take this problem up again in week number 8. This time, I did not ask you to formulate the problem. I converted into a TDMA problem, and then you could use the TDMA algorithm in order to solve the problem. Okay, but again, that would be one example. The nonlinear equation, I've taken an example from a bacterial sludge problem from environmental engineering. Week number 6, I'll take up a problem from, for example, population dynamics, how the population dynamics work, and so on. Week number 7, I'll take an example from electrical engineering, for example. Week number 8, I'll take a couple more examples. So I've taken examples from physics, from electrical engineering, from mechanical engineering, from chemical engineering, from civil/environmental engineering. One examples each, or a couple of examples at various points. From chemistry, I've taken the example of a non-ideal gas equation. The gas equation that we took is what is known as Peng-Robinson equation. So we have taken several examples during the course. These examples were necessarily simplified versions of what capability Matlab, for example, has. So Matlab does not necessarily solve, 5x5 or a 6x6 type of a problem, the one that you solved in TDMA. But for example, something that I use in my research is the TDMA. The size of TDMA is 1000 by 1000 or 5000 by 5000, and larger sizes than that. Okay, ODEs that we are going to solve in week 7 and week 8 won't be 1 or 2 or 3 ODEs, but maybe 20 ODEs, 10 ODEs, 5 ODEs, and so on for the same application problems. So yes, so whatever problems that you are looking at, you just expand around it to bring in more complexities that a real world faces, and those are the kind of problems that MATLAB will be able to solve for you. Okay, it's much more popular also in process control and control simulation and signal processing areas as well. Okay. What is the exam pattern? I have answered that question. Approximate weight module wise, I've answered. Duration of the exam is 3 hours. 3 hours should be reasonably sufficient for the exam. It's a 3-hour exam. Abhishek's question, can you please tell whether it is NPTEL guidelines to provide some sample questions for the exam for any course? So Abhishek, I don't exactly know what you mean by sample questions, but okay, so these are basically soft guidelines where we don't disclose the actual questions that would be asked in the exam. Exam patterns we do disclose, but again, it actually depends on course to course. So there would be certain courses where disclosing the exam patterns, some faculty may not want to do for good reasons. But in general, we like to kind of disclose the exam pattern, though not the specific questions that would come. Type of questions, yes, but not specific questions. In partial pivoting method, oh, I have done partial pivoting. So ignore partial pivoting, Pooja. For neither in the assignments nor in the exam, I'm asking partial pivoting. I'll answer your question. I'm not avoiding your question. The problem I just solved 1, 2, 3, 4, 5, 6, 7, 8, 10 is the example that I solved without doing pivoting, because the first thing that you would have done pivoting is actually, I will just answer the question now. Why am I waiting for later? So the question, the problem was 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay. What do we do with partial pivoting? First case, the pivot element is this. 1 is the pivot element. Okay. Now, what is the idea of partial pivoting? That the pivot element's value, the absolute value, should be the largest in that particular column. But that's not the case. Which one is the largest? This particular guy is the largest value. Okay. So therefore, in partial pivoting, what we are going to do is we are going to switch rows R1 and R2. R1 and R3 are switched. Okay. How do we do that? I will create a temp variable which has the contents of this row, which is going to be a 1 comma all. So the temp now has value of 1, 2, 3. Okay. Now what I will do is I will replace the contents of row number 1 with the last row. So I will say a 1 comma all is going to be equal to a 3 comma all. What will this do? This will overwrite, this value will be overwritten on in the first row. So at the end of it, our matrix A is going to be 7, 8, 10, 4, 5, 6, 7, 8, 10. Now what do you want to do? What was originally row number 1, I want to insert it in row number 3. How will I do that? A 3 comma colon equal to temp, which will give me A equal to which is exactly what we wanted in this pivoting exercise. Okay, hopefully that that was clear. Okay. Siddharth Kumar, I'm facing difficulty in solving assignment because I'm new in Matlab and many questions are somewhat different from the class teaching. Yes, the questions are a bit different because in class teaching we focus on two things. One is the numerical concepts, whereas in this course we have, if you look at every week, I've split it half and half. The first half, not necessarily the first half, but one half is going to be the concepts. Let's say FSOL uses a variant of Newton-Raphson, so the concept of Newton-Raphson I would have covered in Matlab, or the concept of fixed point iteration I will cover in Matlab. And the next half, I will talk about Matlab commands that are used to solve those type of problems. Okay, so there isn't an equivalent of the second half at all. I mean, that is absolutely unique to this course, and there's no real way I can think of how you would have studied that in a course that is not a Matlab specific course. So that part yes, I agree. It's a new concept. It's a different concept. The way you can learn is, as I had said half an hour back, is look at the videos, pause the videos, try to solve the same problem by yourself. If you're stuck, look at the videos, quote unquote, copy paste my code. You'll again get an error. Try to figure out what that error is. You're stuck. Ask the TAs or your fellow students in the forums. So these are the ways that I can think of. So those are the ways that work. What really works in any kind of a coding course is just coding by yourself. Okay. And again, I have not edited any of the errors that I have made in the videos, just to emphasize to you that making an error while writing lines of code is part and parcel of that coding. You will write 5 lines of code, test it, you will realize that there's an error in third line, you change it, you test it again, keep debugging. That is how it works. And if you stick with me and try to solve the same problems that I have, that is something that will work. If you also have noticed that the number of video hours is just 13 hours, but don't get misled by 13 hours, because they are highly edited. The original videos were around 26 hours or 25 hours, which have been edited to 13 and a half hours, so that you can really focus on things that are most important to you, so that you don't spend too much time on rest of the stuff. You can pause the videos and follow the material. But those 13 hours of video material is going to take at least 2.5 to 3 times that much amount of time to get a good hang of MATLAB. So probably 40-50 hours of time spent, plus another maybe over the 8 weeks. So approximately 6 hours per week is what I would think you would need to spend. What was the show matrix code? Meghraj, I have not shown the show matrix code because it ends up creating more confusion. What is the better way to take a matrix input? Soham, I'm not sure I understand your question. The way MATLAB uses matrices is exactly the way you will use any scalar, except for the fact that matrix follows rules of matrix addition, multiplication, and so on. Other than that, with respect to coding, it takes in the variables exactly the way it would treat any variable, including scalars. So I'm sure I did not understand your question correctly. Uh, develop skills in Gauss-Seidel methods. If you use I equal to 2 to 4, then I equal to 3 to 4. I want to do it with a nested code, then what is the code? How about this? In the last live session, you tell me how you did it. Hopefully by then you will have your answer. This is week number 5. I will have a live session in week number 7. So the next live session, why don't you give the answer over there? Just tell me that, okay, you had asked this question, is this the answer, and I will reply it at that time. I'm not avoiding the question. The answer is fairly straightforward. There will be an outer for loop, there will be an inner for loop. The inner for loop won't go from 1 to n. It will go from one value that depends on the outer for loop. So that's the hint. Try it out. Think about it. See if you are able to get it. Ask your friends. Ask your colleagues. Ask on the forums. Hopefully, you'll be able to find some ideas yourself. Okay. Don't be shy about trying out ideas, even if they turn out to be wrong. That's the best way to learn. To try out ideas and to find out, yeah, they are right or they are wrong. And if they are wrong, we learn. If they are right, great, we have already solved the problem. Okay, that's really my suggestion, not just for this course, for absolutely any course. Online version of MATLAB, is it same as offline version? As far as this course is concerned, yes. As far as around 75% of the things are concerned, yes. The primary difference in the online and offline is the online version does not have the GUI based tools in MATLAB. So I have one more course that I run this semester. It's called Model Predictive Control course. In that course, students are using offline version because there is a tool called a MPC Designer tool, which is a GUI, graphical user interface based tool. GUI tools are not available in MATLAB Online, but all other tools, all the command line tools in MATLAB are available in MATLAB Online also. Whenever new toolboxes come up, they first get released on MATLAB offline and then they come onto online, probably in 6 months to a year later, perhaps. I don't know. You may want to ask MathWorks about it or go to MathWorks site to know exactly about it. But I would say 75% of the things are the same. Okay, there are small differences, but for all students in this course, they are nearly the same. How can you generate mesh grid of 10 by 10 using MATLAB? Just do help mesh and you will be able to find out. I don't remember at the top of my head, so I won't be able to answer the question. But in general, if you want to create a mesh grid, what I would do is I will have equispaced x, I will have equispaced y as much as possible, and I will have f of x comma y based on these values. F of x comma y will have n number of rows corresponding to x, m number of columns corresponding to y, and accordingly MATLAB will take those points. Okay, but again, you can look at the help for mesh grid and you will be able to know. MATLAB, yeah, Meghraj, if you copy and paste C++ in MATLAB, you'll have to make a few changes. And the major change is because C++ array starts from 0. The other major change is basically you can use, for example, the concepts of vector and matrix multiplication to do a whole lot of things much simpler in MATLAB than you need to do in C++. So those are the things that are going to be different. Okay, but yes, the biggest confusing part is the fact that C++ has index 0 in its arrays, vectors and matrices, but MATLAB starts with index 1. Can we import data from Excel? Yes, but not the GUI. So I think the import data would be from XLS read. I think I'm not sure whether it's allowed or not, but you will not be able to use the GUI version, and there needs to be certain compatibility issues. But I really don't know about reading from Excel, but reading from text ASCII text file, it is available in MATLAB online also. Excel, I do not know. Okay, and now the question from Abhishek that I had left, I will take this up. Okay, Gauss elimination is essentially, when we solved a 2 by 2 or a 3 by 3 problem in 9th, 10th, 11th standard, what we did is essentially codified in Gauss elimination. Now let's take a look at the problem. So let's say we have 2x plus 4y equal to let's say 6x plus 2y equal to 3, x and y equal to 1 over here. So you know that, right? So what do? We do equation 2 minus equation 1 by 2. Why do we do that? We do that in order to eliminate x from this equation. What will that give you? It will give 2x plus 4y equal to 6 and 0. Ooh, sorry, I should have used something else. Okay, this plus y equal to 4 minus 3, and that is going to be equal to 1. Okay, so this is Gauss elimination. So you started with 2, 4, 6, 1, 3, 4. Okay, then you did R2 minus half R1, that left with 2, 4, 6, 0, 1, 1. Now you can do back substitution. Okay, and when you do back substitution, you're going to get y equal to 1. You put y equal to 1 over here, you will get 2x plus 4 equal to 6, therefore x equal to 1. That is essentially what Gauss elimination does. What does pivoting do? Okay, you don't necessarily always use E2 minus equation 2 minus equation 1. Sometimes you might actually write equation 1 minus 2 times equation 2. Okay, when it is computer, when you are expanding it to a 100 by 100 system, you can't arbitrarily do everything like this. What you will then do, instead of this, you are first going to do exchange of equation 1 and equation 2. Okay, and then you will do this step. So what was that? That was the step that pivoting is about. Okay, of course you won't do this business over here because already 2 is the largest value in a11 element. But let's say if the equation were reversed, x plus 3y equal to 4 and 2x plus 4y equal to 6, if those were the equations, you would have first switched them around before doing this task. And that is essentially what is codified in uh, Gauss elimination. What is TDMA? TDMA is nothing but Gauss elimination for a specific type of matrix. If we know that the matrix is of the form, let's say star, 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 okay, then first is this is the pivot element. Okay, in Gauss elimination, what did we do? We did R4 minus alpha 41 R1. We did R3 minus alpha 31 R1. R2 minus alpha 21 R1. Right? But because of the tridiagonal structure, we know that these guys are 0 already. So we know a priori that this value is going to be 0, this value is going to be 0. If we know a priori that they are going to be 0, why even do these calculations? If we are not doing these calculations, this is the only calculation we are doing. If this is the only calculation we are doing, we have saved the amount of effort in doing this calculation. Once this happens, you get notice what else happened. This value did not change. Why this did not change? Because we know a priori that these values are 0. So you are not doing those calculations at all. These additional 2 calculations are also not being done. So the only calculation that is being done is you're using R1 to make the pivot element in R2 column, the pivot column element in R2 0, and you're not touching any of the other elements except the first and second element in R2. Okay, that essentially is TDMA. Okay, in this particular Matlab course, you don't even have to do this. All you need to do is to extract this particular diagonal and put it in D, extract lower diagonal and put it in L, extract upper diagonal and put it in U, and then call my okay. This is what was expected in that assignment problem. Okay, hopefully that clarifies Gauss elimination. What's the relationship between TDMA and Gauss elimination. And what does the command, the code my TDMA, that was a code that I created, but what does that code do and how to use that code? So hopefully those things are clear to you. Okay, so let's see maybe a final set of questions. We're already a bit late. Can you please show difference between Ooh, okay, Abhishek, let's wait for week number 6 and you will see. Okay, the difference between slash and dot slash is element by element division. So if you have say 1 1 and 2 2, then a slash b will give you an error. A dot slash b will give you 0.5 0.5. So dot slash is element by element. Backslash is left inverse, regular slash is right inverse. Okay, what does left inverse right inverse mean is, let's say you have AB equal to CD. Okay, let A, B, C and D all be square matrices. Okay, you can multiply throughout by C inverse and this becomes this. So this you can see is inverting from the left side. Okay, on the other hand, if you have this is inverting from the right side. Okay, now straightforward, when when C and D are invertible. In certain cases, C and D may not be invertible. In certain other cases, C and D may not even be square matrices. In which case, left inverse and right inverse have specific meanings. What do we mean by that? Is if we want left inverse, okay, then this is what we are going to have. Okay, this particular guy is called the left inverse. Okay, that is the concept behind it. Wait for week number 6 regression and hopefully this will be more clearer then. Is there a way to download we wrote in Matlab for future reference? The ones that you wrote, yes, absolutely. If you are using online Matlab, just back it up later on. There's a download button. You can download. If you're asking me to provide those codes, sorry, I will not be providing the codes because there's a way that the codes get to the internet and so on. So please don't share your codes because there's a big value in students writing their own codes, even if it means copying from the screen. Okay, and those of you who have done this copying from the screen, you know that copying from the screen is not as simple as copy pasting from another code, right? And that extra difficulty is essentially the reason why students will be able to learn in a better way. And that's why I'm very, very reluctant to share the codes. I've not shared it in the last 6 years, and I don't intend to share them now. I'm sorry, I apologize for that, but that's a policy that I have reached as a teacher based on what I think would be an effective technique for my students. Okay, Gauss-Seidel is iterative method. Gauss elimination, yes. Okay, I don't know which question. Oh, Gauss-Seidel. Okay, I'll talk about that. Can I when I put an error iteration in both C++ and MATLAB? Yes, because C++, no, the difference is neither obvious nor it is your error. The two softwares work in slightly different manner. The way they handle variables is the reason why this happens. One. Second is, although both of them work on ANSI standards, there is a slightly different way in which the tolerances or the least count is handled. The reasons might be related to that. Most obvious reason that I can think of is that you have certain integers that are present. You cannot do integer calculations in C++ without first converting them into real numbers. So which is where, so you would have defined everything as real numbers, whereas MATLAB will define it as integers till the first time you do real number calculation. So there's 10 to the power minus 16 errors that creep in right at that conversion, and those errors kind of build up as more and more iterations go on. So it is possible that there is an error. It is more likely that there's no error. It's just that two softwares behave slightly differently. Okay. So with that, I will come to the end of this session. Only thing that I have not done is answer the question about difference between Gauss-Seidel and Gauss elimination, which I would do in the next 2 minutes. And then we will call an end to this session. We're already 15 minutes behind schedule. Okay, so we'll take up this example. Okay, so 2x minus 4y equal to 6. So what I will write is, I will write the first equation as x equal to 3 minus 2y. I take 4y onto the left hand side and divide by 2. Okay, then what I will write is 3y equal to 4 minus x, or y equal to 4 minus x divided by 3. Okay, let's take our initial guess, x0 equal to, 0, y0 equal to 0. Okay, first iteration, I will use this equation in order to find the value of x. If I use this equation, I'm getting 3 minus 0. So x1 equal to 3. y1 is 4 minus 0 divided by 3. So it is 4 by 3. Second iteration, I substitute y equal to 4 by 3 in this equation, and that is going to be 3 minus 8 by 3, which is equal to 9 minus 8 by 3, which is equal to 1/3. So x2 is 1 by 3, y2 is going to be 4 minus x, so it is 4 minus 1 by 3 divided by 3, so that's 12 minus 1, 11 by 9. So I equal to 11 by 9. Okay, oh, actually this should have been 1 by 3. 4 minus 3 by 3 is 1 by 3, and 3 minus 2 by 3 is 3 minus 2 by 3 is 1 by 3. No, 3 minus 2 by 3 is 9 minus 2, 7 by 3. And if I put 7 by 3, 12 minus 7 is 5, 5 by 9. 5 by 9. Then I can put 5 by 9 in this equation and calculate the value of x. Whatever value of x I get, I can put in this equation and calculate the value of y. And I do it iteratively till previous iteration minus next iteration. That difference, that's the error that falls below my tolerance. That is Gauss-Seidel method. Okay. So, well, with that, I will come to the end of this live session. Yeah. So, okay, great. I hope I have answered all, or if not, most of the questions. Sine, cos, tan, x is always in radians. As far as any scientific course goes, assume your x values or whatever your variable values to be always in radians, unless told otherwise. Radians is the natural way of using angles, not the degrees that we started off with in our high school. There's a good reason why we start off with degrees. That's because it's easier for young kids to really wrap their heads around degrees than a whole lot of fractional numbers that radians brings in. But after you finish your 12th grade, leave degrees aside. I don't think I have ever worked in degrees after my first year of undergrad, for example. So yeah, radians is the natural way of doing things. Okay, great. So I hope this was a useful session for all of you, and yep. So I wish you all the best and happy learning. Okay. So thanks, and I will see you 2 weeks from today. So next to next Thursday is when I will see you again. Thanks, and have a nice day. Bye.